Alrighty, here we are for our first Lab 1 video. Woohoo! Lab 1. We're so excited. So we are logged on to Blackboard and we are going to go under weeks 1 through 4. And we are going to go, we went to content first in case you're confused. Content, weeks 1 through 4. And then lab assignment 1. And here we see that we have all of our Word documents and our data files for our first lab assignment. So I already have these open, but you'll want to download the Lab 1 instructions, the Lab PSPP guide, and the data file. So I saved everything to my desktop from Blackboard, and I open up my instructions first. So you'll want to read this Lab 1 assignment first, and you will say, okay, each lab assignment has 3 parts: bookwork, PSPP output, and lab questions. So you are going to do bookwork, so I've listed here for you at the very beginning the chapters, the pages, and the problem numbers that you'll do for your bookwork. So you can see for the first lab assignment you have problems from every single chapter, chapter 1, 2, 3, 4. Now I would not wait, and I would be working on these as we learn about them in class. It'll be much easier that way. And then you're going to have a short PSPP assignment. So you will create output from in the program. That's what I'm going to show you today. And save it, and you'll answer questions about that output. So you're going to have 3 components to each lab assignment: bookwork, PSPP, output, and lab questions. So you can turn in your lab assignments late, but they will be deducted 10% of your total points. And I tell you how many points. This assignment is worth 50 points, 40 for bookwork, 10 for PSPP. And so you have to know that you'll get a deduction in points for that. But what you will be submitting is all 3 parts stapled together. If you don't want to print out the PSPP output, you can upload it as a PDF on Blackboard. I'll show you how to do that. So I'll say, okay, here's your lab assignment. So you'll do your bookwork that was listed above, and you will get intro lab data file, right? This is the intro lab data. That's the file you'll download from Blackboard. And it has these variables: weight, race, happy marriage, and area code. And you're going to answer these 3 questions about it. And you'll turn all of this in, and it's 50 points, so you get some reminders here. But let's look at the PSPP guide, and let's do a little demo for you, and then we'll come back and talk about our assignment. So the second document, the how-to guide, right? This is about how to get to know PSPP. So it starts off with the reminders. So here's our reminder about level of measurement. So we want to be reminded of what nominal, ordinal, interval, and ratio level of measurement is, because we're going to need to be able to identify the appropriate level of measurement in PSPP in order to know which analyses and which graphs and what is appropriate for our data. Now I'll remind you, we start at the bottom with nominal. Nominal level of measurement is when we have something that's just categories, just names, right? So a good example of this is gender, male and female. So female is not twice male. It can't be quantified. It's just a label. Our names is another great example. My name is Amy. That is just a label. It doesn't mean anything, doesn't have any order to it. It's just a label. Now, as we increase our level of measurement, we get to the next level of measurement. It's ordinal. Here we have labels, categories, but these labels or categories are in order, right? So if you've taken a survey where you say, I strongly agree, I agree, I neither agree nor disagree, I disagree, I strongly disagree, that's an ordinal level of measurement. Because we have categories, how much agreement we have, right? We can't measure the exact amount of agreement, but we have these categories, but they're in order. So 1, 2, 3, first place, second place, third place, all of those would be example of ordinal level of measurement. And then we move up to the next highest level of measurement, which is interval. Now the best example of interval is temperature, because here we have categories, names, they're in order, but we can measure the exact amount. And there's exactly the same amount of difference between each category. So temperature is a really good example of interval, because if it's 80 degrees today, which it's not, actually we can see it's 75 degrees today, let's use that. It's 75 degrees today. So if it's 75 degrees right now and the temperature goes up to 76 degrees, we know that's the same amount of change if it goes from 75 to 76 as if it went from 75 to, say, 74. So 1 degree of temperature is the same. We can measure the exact amount of it. Now, in interval level of measurement, we have no relative zero. So it can be negative 20 degrees and we would say, oh, negative 20 is cold, but there's still weather. So if zero is a true zero, we call this absolute zero, then we have the highest level of measurement, what we call ratio level of measurement. Ratio level of measurement is something like age, weight, height, length. So if we're 0 years old, we don't exist. So that would be an example of a true zero. So if you're confused and you think you're not sure if it's interval or ratio, something like salary, well, if you have no salary, you have no money, that would be ratio because that's a true zero. Now, PSPP, in class we talk about these 4 levels of measurement. PSPP actually combines interval and ratio into what it calls scale. So I'll show you that in the data set, and we're going to go ahead and make some frequency distributions. Woohoo, right? So we're going to open the Lab 1 file from our Blackboard site. So you can see I have already downloaded this on my desktop. But because I'm using a Mac, PSPP can be a little bit funny. So I am going to open up this, and it says, oh, I already have some files open. So I'm going to close these really quickly. This is my data that I'm going to use for my second demonstration. So I'm going to say, okay, PSPP, open up. Sorry about that. And this is what it opens up as, a blank data window. And I'm going to say that's open up our file. So I save mine on my desktop, Lab 1. And I can see that here, right? Remember, we watched our Getting to Know PSPP video, hopefully. So we know that each row is one person, each column is a variable. So here I have IQ and I have GPA. Now if I want to see information about the variable, I'll click on the variable view. And I can see the name, the type, so they've got their individual short names, they're numeric, they've got decimals, and they are both scale level of measurement. So if we look at the datas, right, so IQ, can you have an IQ of 0? Yeah, that would be an absolute 0. If you had an IQ of 0, you probably don't exist, you probably are not alive. You can have a GPA of 0, and meaning you have no credits, right? So these would both be like ratio level of measurement. So what I'm going to do is I'm going to show both here's the data file, and this is my output window. I'm going to minimize that. I'm going to show both that's the homework assignment. Hold on, let me find the video, the how-to guide. This is how I like to do the PSPP stuff at home. I would put the instructions on one side of the window, and I would have the PSPP file open in the other side of the window. So you might like to do this when you're working on your PSPP assignments. So you can have the instructions open and the lab file open at the same time, the data file. So let's see what we're doing here. All right, we're going to make a frequency distribution. So we want to know about the GPA variable. All right, so let's go ahead and click on Analyze. This is going to be our main menu that we're going to use throughout the semester, so get used to it. Analyze, Descriptives, and then Frequencies. So this is my dialog box, and so here I'm only interested in, let's say, GPA. So I'm going to move GPA over I clicked on it, I moved the triangle, and it moved into this variable box. So this will always be my list of all the variables in my data set, and this will be the variable I'm interested in analyzing. Now, I'm going to unclick these because we're going to talk about this in just a minute. So it automatically gives me some statistics, right? But right now, all I want is a actual frequency distribution table because that's what we're talking about here, right? So I just have to move my variable over and click OK. And now I have to go back and find my output window. So PSPP is a bit funny in that you have to go find your output after you click OK. So if you have a PC, the little icon will flash and you can click on it and your output will just be like a really small window, and you'll click maximize. It will make the window bigger and you can see your output. In a Mac, I have to actually go find the file. So here is my output. This is what is called my output window. So here, this is my frequency distribution table. So for my variable of GPA, this tells me how many people in my data set have a 1.0, a 2.0, a 3.0, and a 4.0. So it tells me my frequency or my count, right? So 25 people have a 1.0, 47 people have a 2.0, 40 people have a 3.0, and 14 people have a 4.0. For a total sample size of 126. So we would say N equals 126. Now, we know the count, so the frequency of each of these values, and then we know the percentage the valid percent, and the cumulative percent. So the difference between the percent and valid percent is if we had missing data, which we do not, they would be different, but so they're the same, so we're great, we're good here. So this is how you get a frequency distribution table. Now, it was a good thing that we got a frequency distribution table for GPA because there are only 4 values. Now, IQ, we might think that there are a lot more range or lots of other possible values for IQ. So if we had gotten a frequency distribution table, it would have been giant. So I could have gone under descriptives, frequencies, and then if I wanted to do GPA, I could move it, or IQ, move it over into this box. And then I could say frequency tables, I could say never, continue. But I could say, hey, I want to see a picture of my data, so let's draw a histogram and superimpose a normal curve. Click continue. And then when I click OK, my output, let me find my output, it'll just do my histogram for me. It'll show me a picture of my data, but it wouldn't give me a giant table with all of the different IQs. So it's kind of nice to be able to see, and that looks like a pretty normal distribution, right? That should look pretty normal. So you can do a lot with PSPP. This is very convenient. So if you think about if we had to make a frequency distribution table by hand for 126 different people, we did it in class and we had like what? Not even maybe 30. So it's interesting how this saves so much time and effort. Now, we have our histogram, right? So we can use this anytime we have non-nominal data. You shouldn't technically use it for ordinal, but you could if you had nothing else. PSPP is really limited in that histogram's kind of the only real graph that you could use. So technically you should use it only for the higher level of measurement, scale, measurement interval, or ratio. But if you needed to, it would let you calculate it on ordinal. Now, if you had nominal data, coded as nominal data in PSPP and you tried to do a histogram, it would say no, you can't do that with that level of measurement. So just like I just showed you, right, you would click on descriptive statistics or analyze descriptive statistics, frequencies, you'd select charts, then draw a histogram, but you'll want to make sure that you go under frequency tables and choose never, because you might get a really, really giant table for that, right? So all 127 different IQs would be a disaster. That would not be helpful. It wouldn't be a disaster. I'm so dramatic. It just wouldn't be helpful. Now, we've talked about normal distributions, and we saw the picture already of the IQs. Looks fairly normally distributed, and we can look at the histograms, but we can also actually have PSPP do this for us. So I'm going to go back to analyze, back to descriptives, back to frequencies, and I'm going to move both IQ and GPA. I can actually click Control or Command if you're using a Mac, highlight both at the same time, and click them both over. And I am going to say, we're going to talk about mean and standard deviation, minimum, maximum, just 1 minute, but maybe I'm interested in skew and kurtosis. So I can actually click skewness, standard error of the skew, and kurtosis and standard error of the kurtosis. And again, I'm going to go to frequency tables, never, because the default is always. Every time you re-click on this, the default is always on. So you will say never if you don't want a frequency distribution table, and then it'll reset itself. You don't have to worry about it. So I click OK, and I have to go find my window. And so I say, oh, look at this. Here's 2 different boxes, right? So I have one chart for IQ and one for GPA, so 2 separate ones. So these are what I requested in the statistics box: the kurtosis, the standard error of kurtosis, the skewness, and the standard error of skew. Same, and here's the kurtosis, standard error of kurtosis, skewness, and standard error of skewness for GPA. So I have them separately. It tells me my sample size, and then it gives me an actual value. Now, if it was a true normal distribution, the skew would be 0 and the kurtosis would be 0. But really, in real life, variables are never exactly perfect. So we have to evaluate this and say, okay, is this going to be normal enough? Now, we're going to learn about z-scores in Chapter 5. So you're going to say, what? You're talking about something from Chapter 5, but I just want to tell you, we could just look at it and say, it's pretty close to 0, right? So we have a negative 0.19 and a 0.04. So this one, 0.04, that's pretty close to 0. So we'd say, okay, when is it close enough to 0 to be normal, and when is it not normal? Now we can just kind of estimate here and say these are really low values, and look at our histogram and say, yeah, it's pretty normal. But we're going to learn a tool called z-scores in chapter 5, and when we have our z-scores, we can actually calculate a z-score for skew and for kurtosis, and this is really easy to do. All you have to do is take the value provided, so here I'm going to say kurtosis, and it's 0.19, and we'll just remember that it's negative, and I'm going to take that kurtosis value, and I'm going to divide it by its standard error, so the second value here. So 0.19 divided by 0.43, and this gives me 0.44 blah blah blah, right? So I'm going to round to just 0.44. So z-scores, as we'll learn, will give us a critical value to make a comparison to. So we will say our comparison value here is 1.96. So when we calculate a z-score by dividing kurtosis by its standard error, which was 0.44, if that value is more negative than 1.96 or more positive than 1.96, so anything below 1.96 is going to be normal. So 0.44 is nowhere near 1.96, so we would say, yep, definitely a normal distribution. So we have a normal distribution here, and so we'll think, okay, we're good. We don't need to worry about skew and kurtosis. We have a normal distribution here. So let's talk about our Chapter 3 and Chapter 4 material and how PSPP can do that for us. So again, I'm looking at my PSPP how-to guide for Lab 1, and I'm actually not going to use my Lab 1 data set anymore, so I'm going to close this, and actually I'm going to close my output as well. So remember, I always start off with a reminder, okay? Measures of central tendency, what are they? We have our mean, our mathematical average, so it's the sum of the x's divided by n. What's n? N is the number of scores or the number of people in our sample or in our data set. Then we have the median, right? The median is the literal middle. So if we had 5 values, we put them in order from smallest to largest. The median would be the middle number with 2 values on one side, 2 values on the other side. Now the mode is just the most frequently scored score. So the value that is most shown or most frequently selected by participants. Now we talked about variance and variability in Chapter 4, and PSPP actually calls this dispersion, but we don't need to worry about that. It's the same exact thing. So other than describing where the middle is with the measures of central tendency, we need to be able to show how spread apart or how close together those scores are around that mean. So are people really similar? Are they really different? So we do have several measures of dispersion or variability that we talked about. We talked about the range, the interquartile range, standard deviation, and variance. Now we don't need to worry about interquartile range because we're not going to do that in this class, but regular range is simply like the largest number minus the smallest number, and we can use the upper and lower real limits if we want to be real technical and we have a high level of measurement, and being precise is very important to us. In this class, we're not too worried about that, right? So we just take the biggest number minus the smallest number, and it just tells us how many possible values of range there is in our data, right? So that's not too helpful. It's a very crude measure of variability. So we're usually going to use variance or standard deviation. Now, standard deviation is really the gold standard. Standard deviation is the average distance of all the scores from its mean. And so the variance and the standard deviation, they're like cousins. So imagine you can't get one without the other. The variance is what you're going to calculate first. It's the average squared distance of the score. So the mean, you take the square root of the variance and you're going to get the standard deviation. So the standard deviation, this is the definitional formula, right? We're going to have what is called the sum of the squares. So it's going to be each x minus the mean, the deviation or the difference of each individual score from the mean. Once we have those deviations, if we were to simply add them up, they would add up to 0 because the mean is the balance point of the distribution. So we have the same amount of weight below the mean, the same amount of the weight above the mean, so they'd add up to 0. So what do? We take those deviation scores, we square them, get rid of the negative signs, add them up, we get the sum of the squares. Once we have the sum of the squares, we divide by n, the total number of scores or people that we have, and that gives you the variance. Because the variance, right, is the average squared distance of the scores from the mean. Then we just have to simply take the square root and we get the standard deviation. Now that's a lot of work, right? I know you're like remembering your flashbacks to class and thinking like, that's a lot of work. So we can actually click a couple buttons and PSPP will do this for us. Now this is how most people get their statistics, is software, right? If you become a researcher or you go on into research or statistics in psychology or social science, you'll find that pretty much everybody uses the software. It's not something that you usually do by hand. Okay? So here we have a reminder of, based on our level of measurement, what measures of central tendency can we use, and what measures of variability can we use, and then what graphs can we use. Now this is really important because we have to be able to identify level of measurement and then know, based on what we have, what level we collected our data at, what measures of central tendency can we use, and what measures of variability can we use, and how can we display our results. So the lower the level of measurement, the less we can do with the data. So if we only have nominal level of measurement, we only have names, we only have categories, like say gender, only know if it's male or female, we can only say the mode. Which one occurred more? Do we have more males or do we have more females? There's no measures of variability we can use, and we can only graph our results using a bar chart. Now say we have ordinal level measurement. We have first place, second place, third place in a race, right? So we can, that doesn't make sense. In a race, we wouldn't have multiple people doing first, second, third. So let's say that we had t-shirt sizes, small, medium, large. And we'd say which one was sold the most. That would be the mode. And then we could report the median or the middle, right, value, which would be, you know, if they're in order medium, something like that. And we can say the range. And we can display this by bar chart. Now, if we have interval level of measurement, like temperature, we can say mode, what was the most frequently occurring temperature this week? What was the median temperature? What was the literal middle temperature? And what was the mean? What was the average temperature? And we have interval level of measurement because we're measuring the exact amount of the quantity, right? We can use range, variance, and standard deviation, and we can display our results in a histogram. Same thing with ratio. We have the highest, best quality, most detailed, most precise level of measurement. So age, right? We can say what is the most frequently occurring age in our class, what is the median or middle age in our class, and what is the average age in our class. And we can calculate the range of ages, the variance of ages, and the standard deviation of age and report that as a histogram. Okay, so on to our PSPP part. You're going to love this. So remember how much fun it was learning how to calculate all these things by hand, doing all that math and using those calculators. So now I'm going to open up my PSPP and I'm going to say File, Open, and I'm going to find on my desktop my employee data. So this is just our demonstration. Remember, when you do your homework, you're going to use a different data set. So in these videos, I'm always going to show you what to do and what to click on. Now remember, you have the written instructions in the guide here. But for your assignment, you're doing the same thing I'm demonstrating for you now, but you're doing it with a different data set. So you don't want to use the employee data set for your homework. You're just learning from it. Okay? So we're ready to get these descriptive statistics. So we're going to Analyze, Descriptives, and we're going to go to Frequencies. So here my dialog box opens up, and let's see, what are we using? We want to know education level, month since hire, and previous work experience. So let me find these over here. So here's education level, where's month since hire, and what was the other one? Education level, month since hire, and previous experience in months. So I moved my 3 variables over by highlighting them in this list over here, clicking the little triangle. And let's see, what do we want? We are going to use the statistics menu here, and we are going to get all of these measures of central tendency. So we're going to do mean, median, mode, and we're going to get our measures of variability. So we're going to get standard deviation, variance, and range. So that's easy. So I just click. I'm going to unclick these guys, right? So I'm going to say, okay, I want mean, standard deviation, variance. I'm going to get my range, my mode, and my median. So it might be easier to think about it in terms of, and I can make this a little bit bigger so we can see them all at once. Mean, median, mode, standard deviation, variance, range. And you know what? I do not want frequency tables this time. There's just going to be too many tables. So I click on frequency tables and I'm going to say never, right? So I'm going to click continue. Now if I wanted a histogram, I could click charts and I could click draw histogram, superimpose, but I know, right, that job category or education level, that might be nominal level of measurement. We'll find out. So it might not be appropriate to do histograms. So we're not going to do that, but we could if we wanted to. Click OK and find our output window. And here we are. I have a box for each variable. So here's education level in years, okay? Oh, it's in years. So that's years would be ratio level of measurement. So months since higher, months would be ratio as well, and this one's in months as well. So we're good. We got high level of measurement here. So it tells me first thing in each one, what's my N? How many people do I have in my sample? 474. So of years of education, the average year of education for these employees in my fake data set is 13.49. So about 13 and a half years of education. So if you think about our education system in the US, the 12th grade is high school, so 12 years of education would be like a high school education. So the average employee at this fake company has about a year and a half of college work. So they've graduated high school and had at least a year and a half of more of education after high school. But the most frequently reported years of education was 12. So most frequently found in our data set is people who've graduated high school, and the standard deviation, or the average amount of difference, is about 2.8, so almost 3 years difference. So 3 years is not that high. So I would say that the employees at this company are pretty similar in their range of possible years of education. And then we have our range, so the highest number minus the smallest number, so it ranges within 13 years. Now let's look at months since higher. So here we have the average months since higher is 81.11. Now whenever we have multiple modes or no mode, we get this little just dot, right? So PSPP says there's either more than one mode or there's not a mode at all in our data. So we'd have to go look at our data to see what the mode is here. And we would have our standard deviation. So on average, we have about 10 months of difference among our employees. So not quite a year, but almost a year. I'd say that's kind of high. And the range here was from 35 months. Now let's look at previous months experience. So on average, the employees at this company have almost 95.86 months of experience. The mode was 0, right? So the most frequently scored score was 0. So the most people reported having no months of previous experience when they're hired. But look at that standard deviation, 104 months. It's more than 104 months, 104.59 months. So there's a lot of differences in months of previous experience at this company, right? Wow, 104. I don't even know how many years that would be. So 12 months in a year, 104.59 divided by 12. Ooh, there's like almost more than 8.5 years of difference among our employees. So there's a lot of variability here, and there's a huge range of responses. So that's a lot. But you see how you clicked a couple boxes, and these values would have taken you a while to calculate by hand. And because we had this in our data, saved in our data, right? Our data was already here. We just opened it up, clicked a couple boxes, and boom, we have our descriptives. So let's go back to our instructions, right? So once we have our box for each of our variables, we need to save it. So we'll go back to our PSPP output. We're going to go to File, Export, and then I'm going to choose my desktop. And I'm going to call this Output Lab 1. And say, okay, that's my name for the file. I'm going to save it to my desktop. And then I go down here, and I'm going to pick the first option, PDF. I'm going to click Save. So let me just minimize these really quickly, and you'll see, boom, here we are. My lab output for lab 1 is saved as a PDF. So if I double click on it, it's a PDF, and I can print this out, I can upload this file, I can email this file, I can save this file, so I am in good shape here. So here we've gone through the whole demonstration for lab 1. Now if I was going too fast for you, please feel free to go back and re-watch this video. But once you have done the practice, so you've gone through the getting to know guide, right, the getting help guide for lab 1, you've gone through all the instructions, you reviewed all the review, you're going to go back to your lab assignment instructions. You're going to say, okay, I did my bookwork, so my 4 chapters of bookwork, these are the problems. You got your PSPP output, right, so you're going to say, what was my PSP assignment? You're going to use the intro lab data file. You're going to do exactly like we just did in our demonstration, but we use the employee data set for our demonstration in this video. You are going to use the intro lab data file, and that lab data file has weight, race, happiness with marriage, and area code. And so you're going to answer these 3 questions about that data file. So what is the level of measurement for those 4 different variables? So you're going to have to look at those 4 variables, and you're going to have to think about it. Based on what that data looks like, are they nominal, are they ordinal, are they interval, are they ratio? And you're going to label each 4 variable as one of the level of measurement. Then you're going to go into PSPP, and you're going to use race and area code, and you're going to make a frequency distribution table just like we just did. So you'll open this intra-lab data file, you'll click on Analyze, Descriptives, Frequencies, you'll move race and area code into the box, and you will have it create the frequency distribution tables for you. And then you're going to go back, and you are going to compute the appropriate measures of central tendency and variability for the 4 variables. So all 4 variables. Now, what does it mean when I talk about appropriate? You're going to have to look at your answers to question number 1. So what is the level of measurement? And say, okay, if it's a nominal level of measurement, what's the appropriate measure of central tendency? There's only one, mode. What's the appropriate measure of variability? None of them. You can't calculate anything if your data is not in order. So you would only report the mode for a nominal level of measurement variable. So you'll have to go through and make sure you really understand and you know which level of measurement each variable is, and then calculate out individually the appropriate statistics. So you'll use PSPP to only calculate the mode for any variable that's only nominal level of measurement. Now, so in the end, you will have your bookwork, your PSPP output will be 4 separate tables, one for each of the variables. You'll have one table for weight, race, happiness with marriage, and area code for showing your appropriate statistics. You'll have a frequency distribution table for race and area code, right? So don't forget when you're doing your statistics that you want to click on frequency tables and click never, or you'll end up with like 10 pages of tables, which you do not need for this assignment. 4 small statistic tables for number 3, 2 small frequency distribution tables for number 2, so that might be 1 or 2 pages, and of course, you're going to, in your output window, you're going to go to File, Export PDF, and save it as a PDF. You can then print or submit it online to Blackboard. So your total lab assignment is worth 50 points. Make sure you pay attention to that due date in the syllabus. They're always due at our review session before exam. And you will have your bookwork, you will have your PSPP output, and you will answer these 3 questions here. You'll staple all of that together. You can handwrite everything you want. I just have to be able to read it. Staple it all together and turn that in at the due date listed in the syllabus. All right, I hope you enjoyed this video. I hope I didn't talk too fast. I'm sorry. I tend to talk fast, and I've done this before, so I probably click the options fast as well. So please contact me with any questions or concerns. Feel free to email or ask me questions in class. Or come to office hours as well. So thank you very much, and I will see you soon. Bye.